2021. This live stream broadcast is a follow-up from yesterday's masterclass session that ANC held here at the conference. And it's an opportunity for us to meet some of the players that were presenting yesterday and get some more in-depth discussion about the ideas that we're trying to put forward from our advisory group. So perhaps starting with you, David, the performance diagnostics that you were talking about yesterday, there is many applications for it, and can you just tell us the types of different mining operations that you've got that you can help people with, and the range of opportunities that you can achieve?
Sure. Thank you, Mark. There's many applications for performance diagnostics, and our benchmark database contains 250 different mining operations. They make up a range of open cut and underground mines across the globe, and our clients seek out our help for a number of reasons. One of the most common inquiries is to obtain a indication of how their mine is performing compared to other mines globally that are similar. So what we're able to do is we're able to isolate from our database of 250 mines, those mines that are most similar to the mine from where the inquiry comes. So that could be an underground mine, it might be a hard rock setting, it could be a particular geography, and a particular location. And so what we're able to do is produce a number of peers from our database that are highly applicable to that deposit, and get very specific about the performance that mine's achieving in every one of its physicals. We also provide that mine with an indication of how they're performing in terms of cost compared to the same peer group. So we're able to really home in on true performance. It's not an opinion, it's based on the data, and that's what our clients really value. They come to us for that information to test their operations and to see how their operations are performing. Some do that on an annual basis, others do it every 2 years or that kind of frequency. We do also see application for exactly the same kind of performance diagnostic data in acquisition and sales settings. So where a buyer, for example, wants to check the upside potential of a purchase, so of an asset, they're able to really get into the detail of how that asset's performing, identify the potential for improvement, and take that as an upside advantage in that acquisition process. So that's another kind of application for exactly the same data. There's this third method that people are interested in, Mark, and that's at the feasibility stage. So when there's a feasibility being carried out or a pre-feasibility study, it's really critical to get those key performance metrics right because they drive the cost. And we're often approached by clients just to specifically understand those cost drivers for their mine in more detail.
Okay, so there is a range of applications for the practical data that's been used. Do you have to go to a mine site to collect this data, or can it be done remotely? How does it work?
So it's great if we can get to the mine site because that speeds the process up, and we're able to sit down with the range of stakeholders and their financial and their operating that have the data that's needed in order to produce the performance diagnostics. And if that's the case, then it can take as little as a week to collect all the information that's required to do a detailed performance diagnostic. Sometimes that's not possible, and particularly with the issue of COVID, sites have restrictions in terms of access, or they're very remote, and they just prefer that a performance diagnostic be done remotely. So in those situations, we're able to gather that data in exactly the same way, and ensure that it is just as comprehensive as if we're there in person. It does take a little bit longer, and it can increase the time taken to acquire the data from 1 week to 2 weeks. But in the overall scheme of things, that's not a huge increase in either cost or time to produce the performance diagnostic.
Okay, and what about the data itself? Do all the other operations get to see the data, or is how is the comparison put forward to people in a practical way?
Thanks for asking that question, Mark. Certainly, we maintain our clients' confidentiality, and we guarantee to do that. So any data that is supplied to us is highly confidential and maintained as private. And so it won't be provided in the form that we receive it to anybody else, and our clients can be assured of that. What we do in terms of the charting is we produce a scatter chart, which has a line of best fit on it that does show other operations and specifically peer mines on that chart, but they're not identified. And sometimes our clients do want to get a bit more specific. For example, if they've got 5 operations and they've asked us to do performance diagnostics on all those 5 mines, and we've just recently done one of those, they might want to see those 5 mines identified on the chart, and we can do that. And another example is that they might want to see mines that are specific to their location or their country, and we're able to do that type of identification as well. But to protect confidentiality, we don't identify individual mines on the charts.
Okay, that's a good explanation of how we can present the information. And I guess the really critical question for people in the Russian market is how many operations have you got that are relevant to cold climates, and are they going to get something that's realistically applicable here?
Yeah, no, great question, and we have a range of Russian mines in our database, but we also have mines from the northern climates, so Canada, and the far north there is also a good example of a very cold climate setting where there's plenty of data collection. So we feel confident that we're able to produce information that's highly relevant to cold climate mining. And a good example of that is a group of 5 mines that we've just completed in northern Canada, 5 underground mines, a very cold climate setting in the winter, and very relevant.
Cool. Okay, so that's a really good background to this whole opportunity. So perhaps if we move on to Jayson, how do you see the optimization and the data collected in the benchmarking database? How do you see that being used in the strategy optimization sense?
Yeah, thanks. Thanks, Mark. In regards to how we transition a lot of what we do in our performance diagnostics into strategy optimization, we take a lot of what we learn from our performance diagnostics in terms of our cost and productivity benchmarks. A lot of that information forms the crux of the strategy optimization, and a lot of the recommendations that come out of any performance diagnostics often lead to key insights into what's going to be the best strategy for the operation.
So you're about the idea of collecting together information from a variety of sources. So I guess there's the benchmarking data on operations. There'll be the geometallurgy data, resource data. How do you go about that exercise of trying to bring all that together and show it in I guess, a succinct way so that people can make decisions about their future?
And that comes down to our hill of value process, where we take into account all options, and I guess really when it comes to the mix of cost, geometallurgy, recoveries, etc., we want to model all of that, and we also want to understand what the corporate goals are to make sure that's forming a key part of the model that we build. So any decisions that are changed there, or anything that comes to light in terms of the strategy optimization process, we have the flexibility to adjust and change any of the inputs that we bring into the hill of value process.
So sometimes I see requests that we get here for mine planning to produce 2, 3, or maybe 4 different schedules, and then some decisions can be made about those schedules. Typically, how many schedules would you produce to create a realistic hill of value type of proposition?
Yeah, great question. It depends on the level of study. So at conceptual, you're typically looking at a fair range of options, mostly because most of what you have in front of you is the unknown, whether it's a large base of inferred resources. So, if we're looking at 3 or 4 options, fundamentally they're based on what inputs are you using. And that determines what those 4 options are going to be. But unfortunately, if we go too far down the process, you're still locked into those 4 options. And to make any changes, you've got to go all the way back to sort of square one, to the production schedules, to then attacking the economic model, to then get a set of results. So with our process, we can produce tens of thousands of options, and we can produce options in the million, and that's what forms the shape of the hill. And that's the key. What we're looking at here is the shape of the hill and how the hill reacts to a multitude of changes. Because even in simple things like the processing costs, I mean, if you use a fixed processing cost and that's determining what your cutoff is, the reality is that's going to change. There's variability in that single item that could have a major impact on your operation, and that's what we're trying to unlock here. Is what's going to happen when you've got an optimal set of prices and a low base of costs. It's what happens when you've got a combination of high prices. What happens when prices are down? What happens if costs are up? What happens if capital costs change? And what happens if schedules change, sequences change, grades change? That whole stream we look at, and we look at every option to ensure that even if you think you've got what's going to be a technically feasible and economically viable project, it's making sure that you've got the optimal strategy.
Okay, so really you're going back, instead of taking 3 or 4 options to quite a lot of detail, the objective is to come back to input parameters that you're confident about, that at a higher level, so that you can do many different combinations across lots of different inputs to really get yourself focused in the right area of the project.
That's exactly right, Mark. And I mean, when it comes to focus and what the key drivers are, that's what we really like to dig into, and that's how we try to find the best value for our clients is really nutting out what are the corporate decisions, what are the key drivers, what are the givens. So what's things like the mineral resource, the location of the mine, the environmental settings, government restrictions. Some of those are just givens. And then we look at what we can change in terms of the size of the mine, the mining method, the sequencing, the cutoff grade, recoveries, all of this. And we look at that mix, and that's what gives us our scheduling inputs to form the best sort of strategic decisions going forward. But it's,
Sure.
yeah.
The obviously a very topical issue at the moment is the environmental and social license questions that many companies face. Do you think that there is opportunity to build into the early stages of planning many of the requirements for environmental and social issues that are going to be relevant to companies when they actually get to production, and how would you go about doing it?
It's a great question, 100%, and that's why we say a lot of the time some of the key decisions are based on environmental factors or social requirements, and we need to take all that into consideration, and that's why when we're setting up the Hill of Value process, we need to speak to all the key stakeholders to ensure everybody's on board.
So I guess it's a good overview of how the strategy sort of comes together. Just bringing Ian into it here, the geometallurgy issues have always been a key driver for AMC in making sure that projects are designed well before a construction starts. So what do you, now that you've done several projects in Russia over the last 2 or 3 years, what do you see as the key issues that face companies operating in this part of the world?
I think the key issue, as I hopefully covered in the talk yesterday, is to get the data collection established at the very outset, and to make sure that the data collection is well aligned. So in particular, the flow sheet that is used for the metallurgical test work really does need to be closely aligned to what is expected from the proposed process plant. Once that's done, then the analysis is a process. It's a process to be worked through. I think one of the key things that we're finding is that it's very much an investigation, because of course, if we knew the answers in detail about what is going to exert control over the performance of the ore at the beginning, then we wouldn't need to do the study. So the studies often reveal new insights about what aspects of the ore are really important for controlling processing in an individual project, and that can be quite surprising. And sometimes there are new things for us and the client to learn.
So what sort of relationships do you see emerging from some of these deposits? I know you and I have talked about hardness as an indicator, and so what types of data can you use? Is it just physical, or can you bring in the logging data if it's available from the geologists? How do you go about that?
Yeah, the objective is very much to make sure that we make full use of everything that's available. And so we would start by looking at the logging data that's already collected and see what we can get from that. Good quality density data is often very useful, because in many projects there's a clear correlation between density and processing performance, in particular the performance in crushing and grinding. Assay data Very often we'll suggest a slightly expanded assay suite, which will give more insight to the mineral content of the ore and of the waste. And increasingly around the world, we haven't come across many examples in Russia yet, but it's becoming increasingly common to use hyperspectral imaging to directly measure the mineral content of drill core in the trays. And there are a number of very sophisticated instrumentation packages available that do a very good job of that. Or you can use smaller handheld equipment to do the same sort of thing. So the objective is to make full use of what's available. We like to start studies by doing a gap analysis to see what has already been collected, and to provide our clients with advice on any additional items that we think would be valuable for their particular ore body in the next phase of exploration.
So I guess the end result of all of this is a three-dimensional model that enables you to identify parts of the ore body that might be a little different, and then perhaps make some recommendations on how to exploit that, that can then move into the strategy and into Jayson's area. Is that right?
That's certainly a possibility. The key is to, first of all, to understand the ore body and the variability, and we build that up from modeling of the data, and then applying those models to the resource block model to create a geometallurgical block model in 3 dimensions. And that, as you suggest, also provides insights as to how the ore varies in 3 dimensions. And may pose particular challenges, in which case our metallurgical experts can often bring to the table new solutions or new ways of investigation that we've collected essentially from around the world.
I guess we've talked then about quite a lot about what happens before the plant starts. But what about after construction is complete? You know, either with our advice or if we're going into a plant that's already in production, what are the differences in the type of data that you might collect and the outcomes that might come from the studies?
Of course, before you go into production, you're entirely reliant upon metallurgical tests conducted on small samples. Once you start the process plant up, all of a sudden you open the tap on a whole range of new data which is coming directly from the process plant, from the data historian, the system that collects all the plant data. So that will include throughput, it will include the energy draw from the comminution circuit, it will include detailed information about mass pull of things like flotation, sulfides, recoveries, etc. And if you set your system up well so that you can, as far as possible, match that information to where the ore is coming from at any individual production period, and the head characteristics of the ore, that is, the head grades of the ore, the rock type, the alteration, etc., then you have a very good data set for, firstly, comparing the predictions that you can generate with production data with the predictions that you generated during the feasibility study from metallurgical samples, and then using the production data to basically combine the production predictions with the earlier predictions and improve the long-term forecasting. So the production data essentially starts you on a cycle of continuous improvement of your geometallurgical models.
So how does that then fit with, say, the digital twin concept that we were talking about at MINEX last time we were here?
So the let me try again. The digital twin idea is that you can model or simulate each part of your process plant digitally, and you can do that either with a variety of different models. You may have a physics-based model, or once you're in production and you have production data, you can build a model of how a specific unit works, such as a crusher or a ball mill, so we say, based on the actual production data. Then by linking that back through the geometallurgical model to the ore body, and you can then have a look at what you're going to deliver to that unit and foresee any potential problems that you may have, for example, in terms of throughput. You can also test that offline, so to speak, with the digital twin. You can see how sensitive that ball mill might be to variations in the hardness of the ore that you're delivering. And then knowing that what the limitations of that circuit are, you can then feed that information into the planning process, so the long-term planning or even the short-term planning, to ensure that you deliver a blend of material to the process plant which is going to process well and meet your targets.
Okay, so that sort of gives us a feel for the range of applications, right through from initial exploration through to operation of the plant. How does that, sort of linking that back to you, David, do you see applications in combining the benchmarking data that we can collect in the pit with the processing information that's being collected to try and improve the overall performance of the operation, rather than treating it as silos, is to unify the information and improve the overall outcome?
Thanks, Mark. Yeah, there absolutely is a very strong linkage there with the performance diagnostics. We're ultimately looking at the total cost to produce a unit of product, whatever that product is. And a key part of that cost is processing. And when we break that down, we often look at the circuit in terms of its grinding capacity. It might have a flotation circuit in it, and also perhaps a filter press component in a very simple analyses. Now, we want to know how those are performing. We also want to know what their cost is, and we'd like to know that with respect to peer operations. So that comparison is something that our clients are interested in. It's key data in terms of the efficiency and the productivity of the site. A key input into that is the geometallurgy, because that can relate to the recovery in the processing circuit. If the geometallurgy is done well, the feed is optimal. It's blended or mined and blended at the right rate, and the recovery in the circuit is optimized, and and the product is produced at the lowest possible cost, and that should come through in the performance diagnostic results and as a comparison to peers.
Okay, so that sort of links all of those together, and then coming back to you, Jayson, obviously the inputs to any strategic plan are critical in developing the outcomes. So as the inputs change, you would want to update your strategic plan. So how often would you recommend doing that? And what sort of outcomes do you see from changing those plans as you go, as you proceed through the life of the mine?
Yeah, it's a good question. In terms of how often it should be done, look, it does depend on the operation, but once a year you should, even if it's just a check that your strategy is still sound and on track, is critical to ensuring that you're still still working down the right path in terms of the strategy that you've selected. When we perform a hill of value, we set it up so that it is flexible, that when commodity prices changes or things change with the mining method or anything along those lines, we can model it and update it so that we can ensure that strategy is still sound going forward.
Okay, so that sort of gives us an overall view of the discussions that we had yesterday at the masterclass. I'm not certain if we have any further questions that need to be addressed. Guys, do you have any additional thoughts that you might like to impart, particularly for the Russian audience?
I'd just like to pick up on what David was saying with regard to benchmarking. And any process plant superintendent knows that the process plant performs best when the feed is as near to constant as possible. So steady state operations produce the lowest cost outcomes and the best recoveries. So to understand variability, first of all, you have to be able to model it in the geometallurgical model, which is one of the key benefits of the geometallurgical approach, is that we do show on a block by block basis how variable the ore is likely to be. And then that can be put into the mine planning process so that the variability is evened out through the scheduling and the operation of stockpiles to produce a feed which is as close to a constant quality as possible. At the benchmarking stage, we can also look at the production data and build various indices of variability and then compare those between different operations.
Okay, so that's a really important point, I think, is that this works throughout the life of the operation, and updating the data is really important. So, all right, thank you guys, or thank all three for joining the chat today, and we hope it's been instructive for those listening. And these will be made available on the AMC website in the near future, and we'll also be dubbing this into Russian and putting it on the Russian website as well. So any further questions, then we can take those and distribute them to the three representatives here from the advisory group. And thanks very much for your time, guys, and we'll talk again soon. Oh, please come to see us at booth 14 at MINEX. Always happy to chat to everybody, and we can arrange to get the guys on the phone via Teams, and we can discuss more detailed topics as they come along. And of course, we'll be here all today and all tomorrow, and we've got a presentation tomorrow morning on the main podium about our experience in assisting Colliers with their Sulco Log project. Thank you very much for your attention, everybody, and have a good day. Thank you. Bye.
Thank you.